Welcome to Global Literature School. Students, this is your first year chemistry class. I am Dr. Jalban and the topic for today's discussion is again very important. That is about different types of yields that are theoretical yield, actual yield and percentage yield. And this topic is from chapter 1. Chapter 1 is stoichiometry. Students, after completing this topic, you will be able to learn what is your learning outcome. But not only this topic, after completing the topic of mole, after completing the topic of limiting reactant, and then after completing the topic of this theoretical yield, actual yield and percentage yield, you will be able to understand the given information from which any two of the following may be determined: theoretical yield, actual yield and percentage yield. If you have given the two types of yield, you can calculate the third one. I will tell you how many types of yields are there. You will be able to calculate the theoretical yield. Theoretical yield basically that we have calculated in our previous topic, limiting and non-limiting reactant. The product that we have calculated with the help of different amounts of reactants, different moles of the reactant, then moles of the product and mass of the product. That is basically theoretical yield. So you can, if you given the values of amounts of the reactants, you will calculate the amount of product. So you can calculate the theoretical yield, and if you have given the actual yield, you can find out the percentage yield as well. Before going into the detail of this yield, you must know what is this word yield. Product, any type of the thing you find at the end of a reaction, at the end of some activity, that is that product, that is yield basically. For example, if you sow some seeds and you have wheat, you have like sugar, you mix something and you make the cake, you make the pizza sandwiches. The product that you have in your hand, that is called, like, basically that is yield. So amount of product or quantity of a product, that is called the yield. For example, sodium chloride, the table salt that is formed with the help of sodium chloride. So this sodium chloride that produced, this is yield. This product is yield. Formation of water with the help of hydrogen and oxygen. So this water that we have obtained, this product is yield. Similarly, sandwich or pizza or burger, these are the yield. So yield that calculated by some equation, like in the limiting reactant, non-limiting reactant, are you obtained from performing some experiment. This product is called the yield. So but we have different types of yield, like theoretical yield, actual yield and percentage yield. So now come to the point, theoretical yield. Theoretical yield basically is like we have calculated in the limiting non-limiting reactant topic, the amount we calculated with the help of reactants moles, reactants mass, that is basically theoretical yield. So the amount of product that obtained from balanced chemical equation, in balanced chemical equation, like we consider all of the reactant converted into our desired product. So such type of yield that is calculated with the help of balanced chemical equation, that is called theoretical yield. For example, formation of water, when 2 moles of H2O reacts with 1 mole of oxygen, then 2 moles of water is formed. So these 2 moles are 36 grams. This is theoretical yield. Similarly, formation of sodium chloride, 2 moles of sodium and 1 mole of chlorine, or 117 gram of sodium chloride. This is basically the calculated values. So this is actually a theoretical yield. But the other one is actual. Now if you actually perform the experiment for like water formation, you have 2 moles of hydrogen, 1 mole of oxygen, you go into the lab and perform the experiment and you get the water. So that mass you obtain in your hand, this is actual. So the yield that is obtained actually performing some experiment, that is actual yield, that is experimental yield. Similarly, sodium chloride formation. So you mix the sodium and chlorine, you got the sodium chloride in a dried form, that is the actual yield. So preparation of sodium chloride, preparation of ammonia, preparation of sodium sulfuric acid, potassium chloride, any substance, any amount, any type of the reactant you perform and you got the product, that is called actual yield. Preparation of alcohol in industry. Alcohol is prepared in large volume, in mass, or you can say the yield. That is called the yield. Formation of sandwiches, pizza, or cake. If you mix the ingredients and obtain the actual cake, that mass, that is called the actual yield. Similarly, like this, I have given you example. You sow the seeds and you give them water. It obtain the sunlight, and lot of time it consumes. And at the end of the day, you have the product in hand in the form of mass. Even it can be in the form of volume. It can be in the form of any unit in the form of moles in the mass. So that is called the yield, and this is actual yield. Like sugar, at the end of the day, you have the sugar in hand, how much it is mass, so that is actual yield. But you know, students, theoretical yield and actual yield. Actual yield is always less than theoretical yield. I will tell you the reason why. But you know, in calculation we consider our reactant converted into our desired product. But in actually, when you perform the experiment, maybe something left unreacted, something move as a vapor, some other reactants are formed. So actually, it basically is less. So a scientist is more interested in the efficiency of the reaction, how much this reaction is efficient. What is the percentage? So dividing the actual yield by theoretical yield into multiplying by 100, then it gives the percentage yield. So if the reaction is more efficient, then he will go for that reaction. But if the reaction is not economical, not efficient, then he will not go for that reaction. Actual yield is always less than theoretical yield. The reason I have already mentioned you. Side reaction may produce some byproducts. Side reactions are those like that are the undesired products. So sometimes side reactions may produce, because we are focused on the one product, but some other products are formed that also consume the reactants, but we consider that only our desired product is formed and all of the reactant completely converted into our desired product. So this may reduce the theoretical yield. Some of the reactions are reversible. For example, in ammonium formation, some of the ammonium formed convert back into the nitrogen and hydrogen. So but in real, in theoretically we consider all nitrogen and hydrogen converted into the ammonia. There is also mechanical loss. Mechanical loss means like in a very simple example, like if you form the cake, you pour the cake into pan, then you take out the cake, and some of the cake left in the pan. So that is loss. That is a mechanical loss. Similarly, mechanical loss may be due to if you filter some product or some distill the product, or if you separate by separating funnel, some left on the separating funnel, some left on the filter paper. During washing, it can move away during washing, during crystallization formation. So lot of mechanical loss. Mechanical loss is in any sense, in any case. If a person is experienced, mechanical loss will be less. But a person is not experienced person performing experiment, mechanical loss will be more. Loss exists, but it can be less or more. It depends upon the experience of the experiment that is performed by a person. So, for example, this is like filter paper. Some of the products can be stick on the filter paper. Even during crystallization formation, you can, in the first step, these crystals are formed, but even if you wait for the next, still crystals are present inside it. So there may be loss during crystallization. This is like distillation apparatus. Some may be lost during this remain in the mixture. So different types of loss occurs, and actual yield becomes always less than the theoretical yield. So then scientists go for the percentage yield, that is obtained by actual yield divided by theoretical yield into 100. A question usually asks, define actual yield, define theoretical yield, give their difference. So write the difference, write the point of difference, their definition, their examples. Give reason. I have already given you the reason. How will you calculate the question number 6, that is extended response question, theoretical yield and percentage in a balanced chemical equation. So the steps for theoretical yield, if you have given the mass, convert them into moles from the with the help of moles of the reactant, calculate the mole of the product, then calculate the mass of the product with the help of moles, and this even will be more clear now. That is clear in the limiting non-limiting topic, but now this next example will clear it you even more. The question is given, following reaction never goes to completion, therefore less amount of ammonia is obtained than expected theoretical yield. So we have to first calculate the theoretical yield. 42 gram of H2 produces 120 gram of ammonia. So in real, when 42 gram of hydrogen and maybe nitrogen will be in excessive, in practically 120 gram of ammonia is formed. You have to calculate the percentage yield. So it means first we have to calculate the theoretical yield. So write the data. Mass of hydrogen is given. Convert this immediately into moles. 42 divided by 2, that is 21 moles. And then again the like ratio formula, like calculate the mole of ammonia with the help of moles of hydrogen. So from balanced chemical equation, 1 mole of nitrogen gives 2 moles of ammonia. Sorry, 3 moles of hydrogen gives 2 moles of ammonia, like this. And 1 mole will give 2 by 3. And 21 moles will give, multiply this, and it gives the 14 moles of ammonia. So with the help of 42 grams of ammonia, H2, 14 moles of ammonia form. Convert this back into its mass. So multiplying this moles into its molar mass with 17, that is like 238. So theoretical yield shows that maximum 238 gram is produced, but in actual this is 120. So percentage yield will be actual divided by theoretical into 100, so 50.5%. So this reaction is 50% efficient. So 50% ammonia is formed, and other loss due to reversible reaction in this case. Next, a small piece of pure aluminium that's having a volume of 2.50 centimeter cube. So now you have given the volume as well as density of the aluminium. What is the weight of H2? H2 is a product. So first of all, write the equation. Aluminium reacts with HCl, gives aluminum chloride and H2. So this is the product we have to calculate. So, and this is the reactant with the help of we have to calculate. You have the given volume and you have the given density. You have not given the mass. So first of all, you have to go for the calculation of mass with the help of volume and density. And you know density is equal to mass per unit volume. And the mass per unit volume, and you have given the volume and density. This volume and density, multiply volume with density and find the mass of aluminium. So mass will come 6.75 gram of aluminium. Now convert this mass into moles. Atomic mass of aluminium is 27. So 6.75 divided by 27, you have 0.25 moles of aluminium. Now very easy, with the help of these moles, find the moles of H2. So again same ratio, like from equation, aluminium 2 moles consumes 3 moles of H2 formed. When this is 1, it will be 3 by 2. And when it will be 0.25, then it will be 0.375 moles. Now convert this back into the mass by multiplying with the 2. 2 is the molar mass of H2. So you have 0.75 grams of H2 liberated. Hopefully this is clear. Now another example. How much silver chloride? So here our silver chloride is the product, this one, and is formed with the help of silver nitrate and sodium chloride. Both they have given their mass. Convert them into moles immediately. So their mass, and you have convert them into the moles. And because these all have 1:1 ratio, so this will give the same silver chloride moles and this will give the same, but you go for the calculation. From balanced chemical equation, with the help of silver nitrate, find the silver chloride. This one. Equation shows when this is 1 consumed, it 1 form. When this 0.7076, so this will be 0.7076 moles of AgCl. Now with the help of sodium chloride find the moles of product, again like the same. So these are the 0.88 moles of silver chloride. Now the concept of limiting reactant is applying here to calculate the theoretical yield. Which reactant is given the least amount of the product? So here in this case, this one, silver nitrate, this is given the least amount. So silver nitrate, on the base of silver nitrate, the moles of HgCl, convert them into mass. So multiplying with its molar mass, that is calculated 143.3, it gives you 101.24. So basically this is the theoretical yield, and we have repeatedly calculated in limiting reactant, non-limiting reactant topic, and also in this. Hopefully students, you will be clear now about theoretical yield, actual yield and percentage yield. So actual yield will always be given to you, theoretical yield maybe you have to calculate, and then percentage yield. So now your work is solve the example 1.9, 1.10, and students, you know, in this chapter we have attempt the short response question, maximum extended response question, and now if you have thoroughly understanding of this chapter, then you can attempt the multiple choice questions of throughout the topic. So this is your homework assignment, and this was all about the different types of yield and the calculation. And hopefully this chapter is clear. This was the last topic of the chapter, and next we will start the chapter 2, that is atomic structure.